We're going to start off with a review of the exponent rules we've already learned. Remember, regular numbers are just going to be regular math. So this 10 divided by 4 is just exactly that. You can put that in your calculator. It's going to simplify to 5 over 2. We also talked about when we have division with exponents and like bases, we need to subtract. I'm going to put my 1 there. My exponents, so I have x to the third, and then I have 2 minus 5. We said order matters when we write our subtraction, numerator minus denominator. And we talked about negative exponents go in the bottom. So my answer to this, I'm going to draw my big fraction bar, 5 over 2. My positive x to the third goes in the top. My negative y to the third goes in the bottom, and that 3 becomes a positive. Same thing here. We have 3 times 2, which is just 6. I only have one x, so I don't need to do anything with that. Right? I'm just going to write it down here, 6x to the 10. And then I have y to the second and y to the seventh, and we are multiplying these, so we said when we multiply we have to add our exponents. You could also continue to write it out in expanded form if you wanted, and then you could count them. So 6x to the 10, y to the 9. So today what we're going to do is we're going to look at that law of exponents and expansion like we were doing at the beginning, and we're going to see kind of what happens as our exponents change. So 5 to the 4th we've talked about is 5 times 5 times 5 times 5, but really when we talked about that division, if we had 5 over 5, it's really going to have a 1 in front of that. 1 times everything. Always. So if I put that in my calculator, I would get 625. 5 to the third looks like 1 times 5 times 5 times 5, which is 125. 5 squared is really 1 times 5 times 5, which is just 25. 5 to the first power really is 1 times 5, which is why we get just 5. So now we get 5 to the 0, and that's one of the things we're going to look at here is the 0 power. So looking at our pattern, right, we had 4 5s, we had 3 5s, we had 2 5s, we had 1 5, and all of those were multiplied by 1. So if I have 0 5s, all I have is my 1. Okay, and that's going to be one of our new rules. That one is the only one that is not on the formula chart, where anything to the 0 power is in fact 1. If I have a negative exponent, so we have 1 over 1 times 5, which is just 1/5. 5 to the negative 2, 1 times 5 is 1 over 25. So that negative exponent is going to make sure that we go in the denominator. 1 times 5 times 5 times 5 is 1 over 125. And then 1 over 1 times 5 times 5 times 5 times 5 is 1 over that 625. On the front there, right? This is technically 5 to the negative 4 over 1, and we flipped that to the bottom. We flipped this negative 3 down to the bottom, and notice we have a positive number there. When we're looking at this, first thing is the 0 exponent law. Again, this one is not on our formula chart, but anything to the power of 0 is equal to 1, right? Anything to the 0 power is 1. And a negative exponent, anytime we have a negative exponent, we must flip it to the other side of the fraction and make it a positive. So if you go back to where we were looking in the denominator. So we're going to do a couple of examples with this. Remember, we want to make sure we put a 1 if we do not have an exponent. And we learned when we divide, we need to make sure we are subtracting our exponents. So I'm going to write these out, and feel free, write them out so you don't make mistakes, right? Our A is 2 minus 1 is just 1. B is negative 3 minus 2. Now be careful, use your calculator if you need to. Negative 3 minus 2 is a negative 5. And then I just have my C to the first power. So I have A to the 1, B to the negative 5, and I have C to the 1. And we just talked about that negative 5. Technically, these are all over 1, so we're going to have to flip that to the other side and make it a positive. So my final answer is A times C over B to the 5th. Regular numbers, regular math, so I'm not going to worry about that right now. I'm going to put my 1 here. Now, I do have some negative exponents, so I need to put this negative 2 on the bottom. Now, I also have a negative 3 on the bottom, so it's going to flip to the top. And when we do that, that exponent becomes a positive number. So y is negative 6, y to the 3rd, times z, all over x squared. We don't want any negative neighbors, so we're going to have to flip them to the other side of the fraction. So we're going to simplify this, and they're asking us what n is. Well, n is that exponent. We talked about a couple of days ago when we are multiplying, we need to add our exponents. This does happen to be a negative 12, and that's fine. 7 plus a negative 12 is a negative 5. So if I have a to the negative 5, I don't actually have to flip this one because it doesn't show it as a fraction. And the n was my exponent, so all I would want here is that n is negative 5. Area of a rectangle is always length times width. So make sure you pay attention to that. So if the area is negative 10 x to the 3rd, y, I'm going to put that 1 on the 1 in the z. And that's equal to the length, which is 2x negative 2, z to the 8, right? We got to find the width, right? Well, we know from solving equations we're going to have to divide this. Sorry, that was not a negative 2, so positive 2. The exponent is negative. And now we can look at and see, okay, regular numbers, regular math. Negative 10 divided by 2 is negative 5. And I'm going to have to subtract these exponents, right? 3 minus a negative 2. Negative, negative becomes a positive, so I have x to the 5th. I don't have any other y, so y stays there. And then I have 1 minus 8 on my z is negative 7. And that tells me that I'm going to put that on the bottom because it is a negative. It needs to flip down. This one is a width and a length, and now we're finding the area. Remember, we're still multiplying. So regular numbers, regular math, 15 times 3 is 45. And we need to add these exponents here. So I have 16 plus 0 is just 16. My b, I have b to the 2nd plus a negative 12 is negative 10. And then my c is going to be 34 plus 0 is 34. So I know I have 45. This is a positive exponent, so a to the 16 goes in my numerator. My b is negative, so it's going to go in the denominator. And then my c is positive, so it stays in the numerator. Again, you're going to need to write these out so you don't make any mistakes. Have a great day.